like that.
But what?
Hey, is that all this on here? What?
One thing about using the solver is you don't necessarily have to multiply this all out to use it in the solver. You can leave it like that as long as it's equal to 0. Just be really careful with your parentheses and your signs and stuff to make sure you put it in correctly. Otherwise, the solver won't take it. If you got it all the way to quadratic equation form, you should have gotten this. X is 0.030. And then make sure you go back and actually find the answers. So you should get 0.07 and 0.16.
Casey had,
I'm gonna start doing my ice chart while you guys are doing yours.
I thought emergency might be now orange. Green. Emergency might be. Yeah, it might be.
there's got to be something tricky about it. One's going to be a solid, just watch. No, they're all going to be solid.
No, but I definitely will throw that in your test somewhere.
Fire extinguishers have an expiration
See
date.
if we're paying attention.
So do you just like leave that out and just exclude it?
Where?
Be solid?
Where?
Or you can replace it with a 1. I don't want you to think that there's a 0 anywhere. There's not a 0.
Hey, Max. Don't fire extinguishers have an expiration date.
No,
No, fire extinguishers have an expiration date, right?
So like, this is long.
No, I know, but I'm just wondering what the expiration date of that fire extinguisher is. So she does.
Go look at it.
All right.
Challenging.
I hope you guys got through the chart, but how is this one a little bit extra fun?
Because it's a mess.
It's a mess. We have a cube, we have to foil, there's craziness going on. Now, you can use the solver, but when College Board writes the test, they can't assume that every kid in America who's taking the test can afford this calculator. So there has to be a better way, and there actually is. And it has to do with the fact that this K constant is very small. What does it mean if that K is very small?
Zero.
What does that mean about how far the reaction goes to the right?
It doesn't produce milk.
It produces hardly any products because the products are going to be on top. But that to be 10 to the negative 7th means we get almost nothing on the top. We get almost no products, okay? So X should be a very, very small number. If X is a very, very small number, we can make a certain assumption. And let me tell you the assumption we're going to make. What if you take, this is sort of an aside, what if you take 0.5 and you subtract 0.0001? What do you get with the correct number of significant figures?
0.5.
With significant figures?
499.
But 0.49999 is for decimal places. That's going to equal 0.5,
Yeah.
right? That's an assumption we're going to make, and it's called the 5% rule. If we think that what we're subtracting from the initial concentration is going to be less than 5% of that initial concentration, we're going to have this sort of situation right here. We're going to assume that it's not going to affect our calculation. So what we can do is we can just say 0.5 minus 2x is approximately equal to 0.5. Look what I just did. That is way easier to solve. Okay? We're assuming that 2x is so much smaller than 0.5 that subtracting it is really not going to have an effect on it with sig figs.
What is that called?
The 5% rule. But you do have to check it at the end, and I'll show you how to check it and why it's called the 5% rule.
So,
Okay? So this problem just became 6.4 times 10 to the negative 7th equals 4x cubed over 0.5 squared. You don't need anything fancy to work that out. How do you take a cube root if you don't know how to use that math function on your calculator? Raise
The power
it.
of 1/3.
Yeah, raise it to the 1/3 power. There's a lot of different ways to do that. So we can find here that x is 0.0034. Now, we have to make sure that our assumption is valid, that our 5% rule is valid. The way you check that and you do need to check it, is you take what you are subtracting. So we have 5.5 minus 2x. We take 2 times x and divide it by 0.5 to make sure that that's less than 5%. You guys see what I mean? The 0.5 is what we were subtracting from. The 2x is what we were subtracting. We want to make sure that that's less than 5%, and that makes our assumption valid. And it's 1.36%. So yes, we win. I still haven't answered the question though. The question is, what's the equilibrium concentration of CO? CO is 2x. So again, with the 5% rule, you've got to check it and make sure it's valid. You don't have to use it, but did someone finish this problem early and use the solver? Because if you use the solver, you get 0.00339. 2 sig figs, you end up with the same answer. So you don't need to go through all that pain and trouble and start getting frustrated with your solver. When you have a cube, this is generally going to be valid, so you don't have to worry about it.
Wait, so the 2 times 1/3/4 stuff?
Is 2x. That's what we were assuming is less than 5% of 0.5.